马斯克一直惦记的电动飞机项目，这倒好 ，Ampaire 毅然在美国试飞了。
I've heard so many people talking about impossible missions. But innovation is about challenging our limits. Cars can be driven electrically, but what about planes? In 2015, my co-founder Corey Combs told me about this crazy concept of electric planes. I still remember how excited I was listening to him introduce the project's feasibility. So we established an elite team with profound experience in the aerospace and electric vehicle fields. Venture capital once questioned everything about us, but they turned out to be supportive of the economical and pragmatic approach. It helps us bring our products to market more quickly. We're transforming the aviation industry with new energy so that the skies can be more beautiful.
Good evening. I'm Susan Ying from Ampaire. Aviation is entering the third revolution, and it's incredibly exciting. Over 100 years ago, we figured out power-controlled flight. And halfway into the century, we have commercial jets entering into service. And this enabled us to go faster and farther. However, it also introduced new problems. We are destroying our environment by injecting 895 million tons of carbon dioxide into the atmosphere every year, which is about 3% of the global emissions. And the worst part is, if we don't do anything now, then by the year 2040, we're going to be the highest pollution or for contributing to the global warming. Have you taken a flight in Thomas Cook Airlines or gotten stranded because of its recent failure? Well, these are some of the other airlines that have failed in the past couple of years. These are most regional airlines, and they operate on a very thin margin due to the very high operational cost, mainly due to fuel and maintenance. Another problem is many communities, such as these ones, that are separated by geographic barriers or by high-cost routes. Aviation is literally the lifelines for these communities, and they will make a huge difference in people's lives. So Ampaire's mission is to develop practical, compelling electric aircraft to solve these problems. Our biggest impact is going to be the availability of these flights that are clean or zero emissions, and flights that are efficient such that the airlines can be profitable and passengers can travel much more affordably. And most importantly, the communities will be better connected with flights more accessible by everyone like you and me. So what will this do is that it will unlock a whole new mobility market with a vast number of existing airports that can be better utilized because of clean, quieter, and more affordable operations, as well as new destinations that will be open, such that Asia and Africa are a lot more connected. And with the new accessibility, the total market is estimated at up to $192 billion before 2040. So how are we going to do this? We focus on a total energy optimized aircraft, such as the Tailwind, where we have a boundary layer ingested open ducted fan that's driven by the patented electric power system. And this will enable us to save up to 90% of the fuel cost. And because of the simpler and more reliable system, it will be up to 50% reduction in the maintenance cost. And we start by retrofitting into an existing platform by replacing one of its combustion engines by the electric propulsion system. And also we have a patented swappable battery pack, which will enable the airlines to have minimum ground time. And so we have taken this airplane to fly, and it flew back in June of this year, and it was the world's first electric hybrid airplane that's flown of this size and capacity. And we have flown up to 12 times to now, with the longest flight more than an hour, verifying some of the breakthrough performances, including the very quiet operations. And we also have a very innovative business model by offering retrofitting existing airplanes with our electric power system, as well as a leasing program for our battery packs and engineering services. And the best validation comes from the customers, $70 million of backlog, and we have a pragmatic sizing and from 7 seats, 6 seats, up to 19 seats with our tailwind that will be offered. In summary, Ampaire is connecting people and community from around the globe by making these electric airplanes that are clean and quiet and much more efficient. And we have a strong team that will make this happen. Aviation's third revolution is happening, and we want to invite you to join us for this flight. Thank you.
Thank you. Thank you, Susan.
Thank you.
You can go to the center stage. 我们把掌声送给 Susan。好，我们开始了我们的问答环节，同时提醒一下我们的观众，你们现在可以开始打分。Do you have any questions for Susan?
Yeah. What are the innovative technologies? I mean, it's a battery, so but and maybe some other that you said about efficiency. But can you say a few bullets about innovative technologies, and then the other one? How big should be currently a battery for the huge airplanes, for a Dreamliner?
For the Dreamliner. Okay, so it's not just one particular patent or one particular technologies. As you know, the whole airplane is an overall optimization. And in the traditional aerospace industry, you optimize based on the aerodynamic optimization. And here we're doing a total energy optimized airplane, which is different. It's not just aerodynamic optimized, it's concerning the energy. And in doing so, we have propulsion and airframe integration. Unlike the Dreamliner, where you optimize with the aerodynamics and you hang a couple of engines on the wing, which totally destroy the energy optimization, even though it's a very efficient airplane. So in terms of sizing, in terms of scaling all the way up, well, there's two answers to that. One is that because of the disruption to the market, which unlocks all of those new mobility market, the best way, I'm not sure if you can remember this grid, the topology changes from the hubs and spokes to the point-to-point. Just like in the larger airplanes, the 787 is taking over the A380s market because it's point-to-point, allowing of some of the secondary cities pairs. And now for us, it will be city pairs as well as village pairs. So you will get a whole new market out there. But in terms of scaling, so you don't necessarily have to go to such large scale because you'll open up a lot more communities, which may be secondary or even tertiary cities. And we're having a new grant from the Innovate UK to study this, and it's very, very exciting. So two answers. One is that you may not need to go to that market. And secondly, if you do that, then the batteries will have to improve a lot. Maybe a totally different chemistry. Maybe it's on hydrogen.
Professor Bentley?
So if I can kind of summarize what you just said, that kind of means fewer large planes and lots of small planes?
Well, currently our size is a 6-seat, and our next size will be a 19-seat retrofit of the existing Twin Otters. And so that will be considered as small comparing to a single aisle such as 160 passenger airplanes. However, the market will be dramatically different.
But are you kind of hinting here that it's just not feasible to carry enough batteries for a large Dreamliner, for example? It's just not feasible. In which case, what about onboard power generation? I mean, there's obviously solar, but you mentioned hybrid. How about having something a little bit more conventional, generating power? Or how about power recovery? So are you doing some of this?
So first, to answer your question regarding a larger size. So The current airplanes that have to go to such large size is because a factor that we call passenger seat mile, right? So if you have the seat mile per gallon that could be high by packing a lot of passenger in there, you get that efficiency. But with these new class of electric airplanes, I'll give you an example. An existing two-seat electric airplane is $3 an hour to operate, as opposed to the combustion engine two-seat airplane that will be more than $100 an hour to operate. So you have an order of magnitude difference. That's the breakthrough here. So in order to do the 100-seat, to get that efficiency, like the current passenger mile per gallon, you need a huge battery or something like a big capacitor or something, which is not feasible, like you said. But do we really need to go that high? Or can we have more frequency of smaller airplanes to fly and not flying to these big hubs? You can fly to the small community directly. Why would you want to go through those big hubs with all the congestions?
But I kind of feel like the air traffic controllers are getting very scared of what you're saying now, because the UK has got planes everywhere already, and now you're saying, well, let's have 10 times more, and let's land everywhere. It introduces a lot more problems.
Yes, and that's why there's a future flight challenge that's issued by the UK government. And regarding the air traffic control, right now, most of the air traffic control is still by voice. And how slow would our voice be? I mean, we have the whole digital network that, the message can be instant. So as long as you have the human with the voice control, it slows down quite a bit. In tomorrow's autonomous world, a lot of message is instantaneous. So there's your question. There's the answer to your question in terms of air traffic control. That needs to be changed,
I feel
transformed.
the advantage is going to be more of a private jet experience.
No, we want practical, compelling electric aircraft.
Awesome. Professor Sipakis?
Okay, I'm trying to understand what are the key innovative ideas. One is optimization, clearly, okay? Then how about batteries? How about engines, whatever, motors, motor technology? So what are the strong innovative ideas? And can you say a few words about your main competitors?
Yes, we have many inventions in there. We have several patents in there. It's not just the components. Of course, our partners also have patents.
And we only have
these.
1 minute left, so we have to wrap
so
up.
for example, the cooling management system, then cooling system optimization, the whole integration optimization, as I mentioned. Competitors, aviation, for example, is a competitor. And I mentioned the distinct competitive advantage by going through supplemental type certificate instead of the total type certificate, which is for a brand new airplane, which will take a decade to get. And our supplemental type certificate allows us to get into the market first in the next 2 years.